The beginning, life before oil. Millions of years before the first human walked the earth, long before cities, machines, and electricity, the seeds of modern energy were already being planted. Not in factories, not in laboratories, but in the silent, ancient oceans of a very different earth. Back then, the seas were filled with microscopic life, plankton, algae, tiny organisms floating under prehistoric suns. When they died, they drifted to the seafloor, mixing with sand and mud. At first, it was nothing remarkable, just another layer in the endless cycle of life and death. But geology had other plans. Burial, the slow descent into the earth. Over millions of years, these dead organisms were buried deeper and deeper. New layers of sediment stacked above them, sand, clay, silt, compressing them under unimaginable pressure. The deeper they went, the hotter it became. At 1 to 2 kilometers, the remains became a waxy material called kerogen. At 3 to 4 kilometers, temperatures reached the oil window, between 60 degrees Celsius and 120 degrees Celsius. This is where magic happens. Kerogen breaks down. Hydrogen and carbon atoms rearrange. Liquid hydrocarbons begin to form. This is the birth of crude oil. The migration, oil on the move. Crude oil doesn't stay where it's formed. Because it is lighter than water and rock, it begins to migrate upward, squeezing through cracks, pores, and fissures inside the Earth's crust. Some of it escapes entirely, rising to the surface as natural seeps, forming tar pits and oily springs that ancient people once used. But some gets trapped. And when oil is trapped, a reservoir is born. The trap, building an oil reservoir. A working oil reservoir needs 3 geological ingredients. 1. Source rock, where the oil forms, usually shale. 2. Reservoir rock, porous rock that can hold oil, like sandstone or limestone. 3. Cap rock, a solid, impermeable layer, often salt or shale, that keeps the oil from escaping. When all 3 align perfectly, nature builds a hidden underground chamber filled with oil and gas. These structures can form anticlines, arched rock layers, fault traps, created by earthquakes, salt domes, giant upward-moving salt pillars. These formations can store oil for millions of years, waiting to be discovered. The deep time story: how long does oil take to form? Oil is not formed in years. Not in centuries. Not even in tens of thousands of years. It takes tens of millions of years for pressure, heat, and geology to transform organic matter into crude oil. Every drop we use today is older than human civilization. The evolution into modern petroleum. Once crude oil forms, it can undergo further changes. Gas forms at deeper, hotter levels, creating natural gas reservoirs. Oil can mature into heavier or lighter grades depending on temperature. Reservoirs can crack, leak, or shift as tectonic forces reshape the Earth. Oil fields are therefore snapshots of Earth's ancient past, preserved beneath the surface. The human era, discovery and use of crude oil. Waterproofing boats. Early medicine. Torches and lamps. Construction materials. But everything changed in the 19th century, when drilling technology unlocked massive reserves buried deep underground. This launched the modern petroleum age, powering transportation, electricity, manufacturing, global trade, plastics, fertilizers, and chemicals. Crude oil became the lifeblood of the modern world, all born from ancient oceans and slow geological processes. Every barrel of oil carries a memory, a story written by ancient seas, buried continents, and the slow heartbeat of Earth itself. And beneath our feet, countless more stories wait, locked in stone, shaped by time, and waiting to be revealed through the geologic lens.